talking about an exciting topic called selections. And what selections in Python or any programming language do is they allow you to change the flow of the logic in a program. And so kind of the best way to think about it is if you're old enough like me, you might remember in the 80s and the 90s, there were these little choose your own adventure books where you made a choice for the character in the book, and based on your decision, it would tell you to go to a different page in the book, and it would continue the narrative there based on your decision. Or maybe recently you saw the episode of The Black Mirror on Netflix, in which you were instructed to make a decision for the main characters, and depending on your choice, then the story would change. So this is kind of what happens with Python. And so Python has this thing called selection statements, which allow us to change the flow of a program depending on what the user's input might be. And so you see right here a little example, a basic example of a selection statement. And in this program, we've kind of seen this program before where we try to calculate the area of a circle, and we know that the area of a circle is radius times the radius times pi. And so we've kind of seen this before where we import math and we say we prompt the user enter the circle's radius, and then we have a neat little selection statement here. It says if the radius which the user input is less than 0, you notice there's a colon here, okay, then print out this statement. Incorrect input, a circle can't have a negative radius. That is, if the radius is less than 0. And we all know that a radius for a circle must be a positive number, because there's no such thing as a circle with a radius that's less than 0. All right, so, but if that's not true, then else what we want to do is we want to go ahead with our, if the radius is a positive number, then we want to go ahead with our calculation and then print out the area. So let's see what this might look like whenever we run it. So we enter the circle's radius, and we're going to be a little bit, I'm going to move this up so we can see it a little bit easier. There we go. So we're going to be a little obstinate here. We're going to say the circle's radius is -5, and let's see what happens when we put -5 in. And so the logic of this should be that if the radius is less than 0, then we should get this error statement here. So I'm going to press enter, and that is correct. So the incorrect input is that the fact that a circle couldn't have a negative radius. And so likewise, if we try to run this again, and this time we're going to put in a positive number, and it goes through correctly because it has evaluated that the radius is greater than 0, and so we go to the else statement directly from the if statement. So this is what selection statements are in Python. They're very helpful in the process of controlling the flow of logic within a program. Now your book talks a little bit about this thing called Boolean expressions, and what they do is they allow us to evaluate whether or not a condition is true or untrue. A lot of times this is really helpful whenever we're comparing values, the value of one variable against another. And so when we do that, we will use relational operators in order to evaluate whether something is true and untrue. And there are 6 different relational operators in Python. First, we have the less than, we have greater than, we have less than or equal to, greater than or equal to, and these are the symbols for those. So that's less than or equal to, and this is greater than or equal to. And equal to, when we're talking about a numerical value, always use the double equal signs. And if we want to say it's not equal to, we use the exclamation point and the equal sign, and that is Python shorthand for not equal to. So an example might be if radius is the input of radius is less than 0, then that Boolean would evaluate as false. Or if the radius is greater than or equal to 0, we know in the real world example that all radiuses are greater than 0, so if 0 or greater, so we know that the radius greater than or equal to 0 might evaluate or would always evaluate as true. One thing that your book also lets you know is that true and false are words that are literal strings that are reserved by Python, so you can never use those like as a variable name. So an example of using this Booleans, we've set a declaration that that radius equals 1, and we want to determine if this statement is true or if it is false. Okay, and so here's our conditional statement: is radius greater than or equal to 0? And so because we've set radius equal to 1, then it should print out true. And so let me run this and let's see what happens. And yes, that's true. So it printed out true whenever it ran because that Boolean value was true. But say what if, for example, if I said that radius is -1? Let's run it and see what happens. And again, the answer is false, because now this statement, this conditional statement that we set here, radius is greater than 0, when it evaluates against the value of radius, it says no, it's false, because right now radius is set to -1. So this is the idea of Boolean expressions. You can use them to evaluate whether or not conditions are true or untrue, and are very helpful in making decisions with data input. So your book also kind of takes a little bit of a divergence here, and it gives us a couple of things to look at in terms of random numbers. And in Python, we can generate random numbers. We have the randint function, which is able to generate whole random numbers that are integers between two values. And so, for example, we might want to generate a random number between 1 and 100. And this is you see this a lot in role-playing games where you might have this imaginary pair of dice that determines randomly a decision to be made. And so in that case, if you wanted to generate a random whole number between 1 and 100, you could do this. So print randint or random.randint, either one of those works. And then you have two parameters for the randint function. One would be the first number, and the second one would be the second number. So what this says is print out to the console a random whole number between 1 and 100. Okay. So in order to access this function, we have to import the random class. So always make certain that import random is typed in anytime you are generating random numbers. And again, randint generates a random integer, but if you want to do partial numbers or decimals, then you can just use the plain old random operator, and that will generate a random float or decimal number. So here's an example of using random integers. So we've imported the random class, and then we declare a variable called number1. We say that it is a random integer between 0 and 9. Number2 is a random integer between 0 and 9. So we have number1 and number2. And so what's going to happen when we run this, it's going to generate that random number and store it into the value of this variable called number1. Then we will generate a random number between 0 and 9 and store it into number2. And then we create a variable called answer, and we say we're going to prompt the user to input. Okay, what is the value of number1 plus number2? And you notice that because these are integers, we want to be able to print them out to the console. So we've converted them to a string, and we've prompted the user to enter the value of these two random numbers when added together. And then after that, we print the number1 plus number2, and then the value of the answer that was entered, and then the string is, and then we have this Boolean expression that evaluates answer as to the value of number 1 plus number 2. And so I'm going to just try to run this, and let's see what happens here. Yes, we're going to save it. All right. So random number 1 that was generated is the number 6, and random number 2 that was generated is number 8. Okay. And so it's asking us from this line of code here, what is 6 plus 8? We know the answer to that is 14, right? So we'll press 14, and when we press 14, what's going to happen is it is going to go to this line here and determine whether or not my answer is true. So let's enter here. And yes, that's correct. So 6 plus 8 equals 14 is true, because what it's done is it's validated my value for answer against the actual answer for number 1 and number 2. And if answer equals answer, then that Boolean is going to evaluate as true. Let's run it again, and let's give a incorrect number. So what's 9 plus 18 or plus 8? Well, we know that's 17, but I'm going to be weird and give us an incorrect answer, call it 16, and let's see how it evaluates that Boolean. And that is, again, correct, because we know that 9 plus 8 is 17, so therefore 9 plus 8 equals 16 is false. And so now we kind of know how to generate random numbers for different types of problems that you might do in programming, and we also have kind of demonstrated how to evaluate whether an answer or user input could be determined to be true or false. All right, the next bit of your chapter talks about the 3 different types of if statements. We have just the plain old if, and we have the if dash else, or we have the if dash elif dash else. And so we talked about it earlier about the plain old if statement, and we know that if determines if a single condition is true. Just plain old if might help us to basically determine, as we saw before, if a statement is true. The else is a little, if else rather, is a little more robust, because it can help us to decide which of the statement is true and which is not. So we know that the radius problem that we looked at before, we know that that is an if else, because if, depending on the user's input, it might be negative or positive. And based on that user input, we have 2 different cases. And so similarly, a two-way if else decides which statements to execute based on whether a condition is true or false. And the way that this works is we can, here's a little pseudocode that kind of helps us understand the logic for a two-way if else. Okay, so if a particular type of Boolean Boolean expression is true, then do one thing, but else if it's false, then do something else. And this two-way conditionality helps us to determine the flow of logic in a program. Let's look at a good example of that in real code. And so once again, we've kind of looked at this generating random number. So we've declared number 1 is a random number between 0 and 9. Number 2 is a random number between 0 and 9. And then we say if number 1 is less than number 2, then swap the values of number 1 and number 2. Okay, and so we can do this through this type of code. And what this code does here, number 1 / number 2 equals number 2 comma number 1. What that does is that swaps the values of of those two variables, because it allows us to do subtractions so that we can avoid a negative number. Okay, that's what we're going to do later on. Is we're going to subtract number 1 from number 2, and if say number 1 is 3 and number 2 is a 9, then it would try to do 3 minus 9, and we don't want to go negative on this. So what this code does is it swaps the values of those to avoid a negative situation. And this is an example of a simple if statement. Okay, here's an example of a two-way if statement. So we continue on here, and we say we propose to the user, and we're storing this in the variable called answer. We ask them, what is number 1 minus number 2? Okay, and we prompt the user to enter the value of number 1 minus number 3, and then we put out to the program, if number 1 minus number 2 equals to answer, then print out you are correct, and else you want to print out you are incorrect. Let's see what this looks like whenever it runs. Okay, so here it's generated 2 random numbers. What is 9 minus 2? We know that to be 7. Type in 7, and the flow of the logic is correct because that Boolean evaluated correctly. Let's run it again and see what happens. And this time we're going to give the incorrect number. We know that 5 minus 3 is 2, but instead we're going to be blockheads. We're going to say it's 4. And again, the Boolean evaluates as incorrect, and so we go to the else statement to basically say that no, your answer is incorrect. So in this way, you can use if or if else statements, two-way if else, to determine and let the logic flow within a particular program. Now your book talks about using this thing called nested ifs, and I'm just going to be honest with you, I hate the use of nested ifs. And especially when we are evaluating complex conditions. So for the purpose of this class, I'm going to recommend that you don't use nested ifs at all, because for an end user, they can get messy. They can be difficult to read. And so my requirement for this class is that we always use if, elif, else constructions in order to be able to use multiple conditions or decisions, especially when we have more than 2 decisions. And so we know in this class that we use a 10-point grading system. And so what we've laid out here is a multiple direction statement where we say if the score is greater than or equal to 90, then the grade equals A. Elif the score, or else if the score is greater than or equal to 80, then the grade is to B, a B. Or if the score is greater than 70, then C. Or if it's 60, it's a D. And then finally, the very last one is always going to be else. The grade is F. Okay. And then depending on what the score is that we input for the student, it's going to print out the score as well as the corresponding grade. And so let's run this and let's see what happens with this if, elif, else construct. Okay, so we've run it here and we ask what score did the student make. And so let's pretend for fun that the student made an 87. We know that an 87 is going to be a B, so I'm going to press enter. And we notice that, yes, the student scored 87 and the grade is a B. So what's happened here is when I put the number 87 into the score here, it evaluated, is the value of score greater than or equal to 90? Well, the answer is no, it's not, because it's 87 that's less than 90. So we know that this condition cannot be true. And so we go down to the next elif. Is the score greater than or equal to 80? Well, yes, that's true, because the value of score is 87, so therefore the grade is B. All right, so when we finally got a true statement in this ELIF, it escapes from this whole block of code because we finally have a true. So we have a false here, and we have a true here, and so it escapes from that, and we go down to, and then it puts the value of grade as the string B, and it says the student scored 87 and the grade is B. Okay, so you can use these types of statements if you're familiar with other types of programming language. Maybe you might call them a case statement. I know that's the case in Visual Basic, or in Java it's a switch statement. But no matter what, you can use the if, elif, else construction to be able to deal with multiple types of decisions. Just remember that this will continue to go through each statement until it finds a true statement. So, we might, say for example, we enter in a 57. Maybe the student made a 57. What's going to happen is it's going to go through each of these statements until it finds something that is true. And in this case, a 57 is less than a 90, it's less than 80, 70, and 60. And so finally we get to 57. It says, okay, well, finally, if we haven't had no matches in A, B, C, or D, then the grade is going to be an F. And indeed, whenever I do that, it does come out correctly. The student scored 57 and the grade is an F. All right, the final thing that your book talks about is a conditional expression. We know we've talked a little bit about conditional expressions so far, and what it does is it evaluates an expression based on a condition. And so, say for example, you want to assign 1 to y if x is greater than 0, and minus 1 to y if x is less than 0. Okay? Well, of course, you can use a traditional if-else statement. If x is greater than 0, then y equals 1, else y equals minus 1. But in Python, you can do some shorthand by using this construct. You can say y equals 1 if x is greater than 0, else the value of y should be minus 1. Okay, so that's just kind of some shorthand that you can use for doing conditional expressions in Python just in one line of code rather than 4 lines of code. All right, so